Something extraordinary is happening deep inside America's shipyards, a secret new base built not for sailors, but for machines. Dozens of sleek, unmanned warships are being assembled in silence, each designed to fight, decide, and survive without a crew. China's naval strategists are reportedly alarmed, calling it a game-changer that could upend the balance at sea. Why is the US hiding it, and what are these robot warships really for? Let's go. The quiet shipyard and the robot fleet. Something extraordinary has been happening on the American coastline quietly, deliberately, and almost in secret. Out past the old naval yards and container docks, a new kind of shipyard has come alive, one that doesn't build destroyers or submarines, but machines. Here, hulls the size of small yachts glide down assembly lines that look more like car factories than military installations. Robots welding robots, automated cranes lifting modular hulls, and software engineers outnumbering sailors. This isn't the Navy of the past. It's the future, and it's already operating. But what exactly is this place? Who built it? And why is China suddenly so afraid of it? They call it Port Alpha, a purpose-built shipyard designed not for manned vessels, but for fleets of unmanned surface ships. It's not a sprawling base covered in classified bunkers or nuclear reactors. Instead, it's sleek, efficient, and eerily quiet. From the air, you'd see long, rectangular hangars, assembly tracks running end to end, and rows of dark grey hulls lined up like chess pieces waiting for deployment. Each vessel is born from a design that values speed over grandeur and quantity over symbolism. Unlike traditional naval yards where a single destroyer can take 7 years and thousands of workers to complete, Port Alpha churns out fully functional ships in weeks. The key lies in its modularity. Every ship shares a standardized core frame that can be equipped with plug-and-play payloads. Instead of custom engineering every sensor, radar, and weapon system, these unmanned vessels are built like smartphones. Swap in a new module, upload new software, and it's ready for a new mission. Components are sourced from commercial suppliers, allowing production to move fast and costs to stay low. Think of it as the naval equivalent of Tesla's Gigafactory but for autonomous war machines. Legacy shipyards were temples to craftsmanship. Port Alpha is a temple to efficiency. Each bay operates on an assembly line rhythm. One section fabricates hulls, another installs propulsion, while a third integrates AI systems and sensor pods. You could watch a time-lapse of the process and see ships evolve from bare metal to operational drones in a matter of days. The comparison is staggering. While a destroyer like the USS Zumwalt took nearly a decade and over $4 billion to build, some of these autonomous vessels can be manufactured for a fraction of that cost and time. The math alone is terrifying for America's rivals because in modern warfare, time and numbers matter more than size. Behind this transformation stands a consortium of private defense startups, naval contractors, and public-private partnerships bound together by innovation and urgency. The lead name whispered around defense circles is Saronic, a next-generation defense startup backed by both Silicon Valley capital and Pentagon funding. Saronic's engineers didn't come from naval shipyards, they came from SpaceX, Google, and DARPA projects. Their approach to warfare is algorithmic. They design vessels like software, versioned, iterated, continuously upgraded. Around Saronic orbit a network of partners, legacy shipbuilders that provide certification expertise, classification bodies like the American Bureau of Shipping, ABS, and government agencies buying through flexible OTAs, other transaction authorities which allow faster prototyping and procurement outside traditional Pentagon red tape. The funding numbers are staggering, even if exact figures remain under wraps. Venture capital has poured in hundreds of millions, while defense contracts have quietly escalated from experimental to operational. Each deal signals a shift. The US military is no longer just buying ships, it's buying a process that can scale. Imagine a future where naval fleets can be replenished as easily as consumer electronics, where new vessels roll off the line every month instead of every decade. That's the scale Port Alpha represents. So what exactly are these robotic warships? They come in a family, each designed for a different role, each small but deadly in its own way. The smallest, nicknamed Spyglass, is just 6 feet long, a fast, stealthy scout designed to skim along coastlines and gather electronic signals. Cheap, expendable, and quiet, it can slip into harbors or follow submarines, feeding live data back to command networks. Then there's Cutlass, about 14 feet long, carrying loitering munitions or small missile pods. It acts like a mobile firing platform, capable of launching precision strikes while swarming in groups to overwhelm defenses. Moving up in size, the Corsair class stretches to 24 feet, a mid-range patrol vessel equipped with towed sonar arrays for submarine detection. It can loiter for days, hunting silently in packs. The Mirage is a 40-foot escort ship, agile and fast at over 35 knots, designed to shadow manned fleets or patrol contested waters. The Cypher class, at 60 feet, focuses on logistics, carrying spare parts, fuel pods, or even functioning as mobile workshops. And towering above them all, the Marauder, a 150-foot unmanned arsenal ship, capable of carrying dozens of cruise missiles or acting as a floating base for smaller drones. Each of these ships rewrites the economics of naval warfare. A single Marauder costs less than 1/10 of a conventional frigate but can carry almost as much firepower. A swarm of Spyglass or Cutlass drones can saturate enemy radar, draw fire, and reveal enemy positions without risking human lives. Together, they form what strategists call distributed maritime operations, a web of semi-autonomous assets working in coordination. Instead of one large, vulnerable carrier group, imagine hundreds of robotic ships moving like a digital organism, confusing sensors and forcing adversaries to spend missiles on decoys and ghosts. Mass production changes everything. For decades, navies have been obsessed with building exquisite ships, massive, expensive vessels meant to last 40 years. But in the age of automation and AI, the advantage shifts to whoever can build, deploy, and replace faster. Port Alpha's approach flips the equation. Instead of a handful of billion-dollar ships, the US could field hundreds or even thousands of low-cost, semi-autonomous vessels. It's the same logic that made drones reshape the skies now applied to the oceans. If you could see a side-by-side timeline, an aircraft carrier taking 10 years to build, versus a robotic warship rolling off the line in weeks, the future becomes obvious. Quantity becomes its own form of quality. In a potential conflict, every week counts, every hull matters, and every delay costs strategic ground. That's why Port Alpha isn't just an experiment, it's a signal to the world that naval warfare is entering an industrial revolution of its own. But this story doesn't end with the assembly line. Because to understand why this base exists, and why it has China so alarmed, you have to rewind to the technology, the rivalry, and the quiet arms race unfolding beneath the surface. Why this is happening and what it builds on. What's happening right now beneath the surface of global headlines is nothing short of a revolution in naval power, a discovery so recent and disruptive that it's forcing military planners to rewrite decades of strategy. The United States has quietly proven that it can mass-produce autonomous warships, but the reason it's doing so isn't just technological ambition, it's panic. Because across the Pacific, China's shipyards have been building at a rate the world hasn't seen since World War II. The numbers are shocking, and the implications even more so. How did Beijing gain such a massive lead, and why does the US now believe only robot fleets can close the gap? For years, China has held the world's top spot in shipbuilding, not just for civilian vessels but for warships, Coast Guard cutters, and even fishing fleets that double as state-sponsored auxiliaries. Its shipyards in Dalian, Shanghai, and Guangzhou operate like industrial cities, running 24 hours a day, 7 days a week. At any given moment, dozens of hulls are under construction, from small patrol boats to massive cruisers like the Type 055 Renhai class, each equipped with over 100 vertical launch cells capable of firing long-range missiles. Unlike the US Navy, which separates its combat fleet from its Coast Guard and merchant marine, China's maritime strategy blurs those boundaries. The same fishing trawler that appears civilian on radar can relay targeting data to destroyers or harass foreign ships in disputed waters. This hybrid force, a mix of Navy, Coast Guard, and maritime militia, gives Beijing overwhelming presence in the South China Sea and near the Taiwan Strait. In naval warfare, presence is power. The side that can put more hulls in contested waters wins the battle for information, control, and attrition. In narrow choke points like the Luzon Strait or the Bashi Channel, where every radar contact matters, China's advantage in ship numbers could flood the zone. Even if only a fraction of its vessels are frontline warships, The sheer density of platforms allows saturation attacks, overwhelming enemy sensors and missiles through volume alone. It's a war of exhaustion, and the US can't simply outbuild China using its traditional shipyards. The cost and time lag are too great. That's why the Pentagon turned to automation to fight scale with scale, but through machines instead of manpower. The path to this new generation of robotic ships didn't happen overnight. It began almost a decade ago with DARPA's Sea Hunter, an experimental trimaran that looked like a skeletal sailboat crossed with a stealth fighter. It was the first large unmanned surface vessel to navigate the open ocean, cross thousands of miles, and follow international maritime rules entirely on its own. The Sea Hunter wasn't armed, but it proved a crucial point. Autonomy at sea was possible, reliable, and cheaper than expected. Then came follow-ons like Nomar and Defiant, designed by defense contractors in partnership with the Navy's Unmanned Maritime Systems Office. These vessels introduced no manning-required architectures, meaning every component, from fuel valves to radar calibration systems, could be remotely managed or automated. They also pioneered modularity, interchangeable sensor masts, mission bays, and propulsion pods that could be swapped in hours instead of weeks. What started as experimental prototypes gradually evolved into a doctrine shift. The Navy began funding not just individual ships, but whole production lines built around autonomous design. The technology had crossed the threshold from laboratory experiment to scalable industry. But hardware is only half the equation. The real transformation lies in how these ships communicate and fight together through something called the kill web. Traditionally, militaries operated with a linear kill chain: detect, track, target, and engage, each step handled by a specific platform. If that link was broken, the attack failed. The kill web changes everything. It's a decentralized, self-healing network where sensors, shooters, and command nodes constantly share data. If one ship is jammed or destroyed, another instantly takes over. Picture this: a small spyglass drone on the ocean's surface detects an enemy vessel using passive sensors. That data is instantly transmitted through encrypted links to a nearby cutlass, which verifies the target's ID using visual feeds. Simultaneously, a distant marauder receives the target coordinates and readies its launch tubes. A human operator sitting in a control room thousands of miles away gives final authorization, and the strike is executed within seconds. No single ship has to carry the entire burden. The web distributes the task, making the network itself the weapon. This approach aligns perfectly with the U.S. Navy's new doctrine of distributed maritime operations, dispersing assets to make them harder to target while keeping them tightly connected through data. The goal is resilience. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe.